the next speaker is Professor Benoit Baudry, and we're so happy to have one of the world leader researchers from France coming to KTH and coming close here and actually being in Stockholm. And I would say really representing the bar we all need to reach up there, so the one we can really learn from a lot. You have done some interesting stuff academically, so welcome.
Thank you. Okay. Hello, my name is Benoit Baudry. So I'm a professor at KTH now in software technology. I joined 18 months ago and I was in France before doing research in software testing. What this slide is saying is that I work at KTH. I'm currently supported by a Swedish program which is called WASP. And I'm also the director of a new research center which is founded by KTH, Saab and Ericsson, and that focuses on software technology research. It's called Kista. And today I am here because another thing I do is that I coordinate a research project, an European project in the H2020 framework. This project is called STAMP. It stands for Software Testing Amplification, and I will go into details of this. And it has 10 partners. There are 4 universities, 4 research organizations, so KTH in Sweden, Sintef in Norway, INRIA in France, and TU Delft in the Netherlands. And then there's one open source consortium, which is OW2. And the 5 other partners are software companies, 2 big ones, Engineering and Atos, and 2 small companies, Activion, XWiki, and TellU. The area of this project is, I would say, back-end software infrastructure and back-end software applications, microservice architectures, and we have a pretty focused technology stack, which is in the area of the JVM, Docker, and the CI. So what we want to do is that we want to increase automation for testing. And so in the title of this presentation, there was the word DevOps. So I say a few words about what I understand about DevOps. So if you see this picture that you all know, so there is this idea that you want this continuous flow between the moment you write a line of code to the moment you commit, build, and deploy, and then have the feedback. So you can think about this continuous loop in many ways. One way that we think about it is that there's lots of technology to make this happen. So we have a very strong focus on technology, on tooling. And so these are examples of tools that you can find along this, this continuous loop. And so one thing that is interesting for us is that many of these tools are actually about testing. So this comes back to what Sigrid was mentioning earlier. If you think about testing, there are many different kinds of testing that you can perform, and many different kinds can be performed along this this continuous loop. From unit testing on your laptop as a software developer, to many things that can be done in the CI, and then online you can also do many forms of testing and many forms of monitoring. So for us, DevOps is a lot about tooling to make DevOps happen, and a lot of these tools are about testing, so that's why we focus on testing. In particular, in STAMP, we focus on these 3 areas. So we focus on unit testing. You can think about unit testing in either on the developer's laptop or in the CI. Configuration testing, this happens in the CI mostly. And we also take advantage of the fact that we have feedback coming back from production in order to increase the tests that we can put in our CI. It's a research project, so we have research organizations who collaborate with companies to explore one new concept. So that's the research part of it. So the new concept is called amplification, so it's part of the name of the project. And you can think about amplification in a very natural way. So if you look at the definition of amplify, this is what you will find. So you know what it is, amplify. You take something and you make it bigger. You increase the sound of music. And so when it comes to software testing, we can really translate this definition of amplify to software testing. So test amplification is increase the effect of test assets. So the idea is that there are many things that exist. Sigrid has mentioned it, millions of test cases, test scripts, containers, the CI, all these things are there, and they can be made better. So the idea is that we use what exists already, what is done by developers, all the intelligence and the information that is put there, and we amplify it through automation, automatic techniques. And so in particular, we focus on three different types of test assets. So we focus on test cases, unit test cases, configuration file and configuration containers, and production logs. So those are the three test assets that we have in mind when we say that software testing amplification is about amplifying the effect of test assets. The test assets that we have in mind are these. The effects that we want to amplify, that we want to increase. When it comes to unit tests and integration tests, it's a lot about the mutation score. So we want to make these test suites better at detecting mutants and at detecting errors. And we also want to make these test suites better at testing different feature interactions. So those are the two effects that we want to improve, and we want to do this automatically. So the last bullet point here is about automation. So we want this amplification to happen automatically. We want to take these things that exist and automatically amplify them. So I will quickly browse through the three different steps and the three different assets on which we are working. So the first thing we do is that we work with unit tests. So unit tests, they exist, they are written by developers, they are running automatically and constantly in the CI. So the first thing we want to know is how good they are, and so for this we work on mutation testing, and as has been mentioned earlier, scalability is a challenge for most of you here, and one of the challenge of mutation testing, and I know that you have been working on this in Testomat, I've seen posters out there. One of the challenges is that it's pretty time consuming and resource consuming to run mutation analysis. So the approach we have taken in STAMP is that we've gone ahead with a new type of mutation analysis, which is called extreme mutation. And basically what it says is that in mutation testing, what you do is that you will take your program, inject many bugs, like replace plus by minus or greater by lower, and you will have many mutants, and then you run all your test cases on all the mutants. So the one part of the time that it takes is related to the number of mutants that you generate. So in this approach, what we say is that, okay, we'll do something a bit more gross. We'll take a method and just remove the body of the method. And so for one method, we either have one mutant. If it's a void method, then the method does nothing. And if it's a method that returns something, then we create one or two or three mutants that return a value, a fixed value. So for example, here, for this method that does things, computes factorial, in this case, we generate 2 mutants. So instead of many that could be generated by a regular mutation tool. So we have fewer mutants. Another benefit that we see and that we have from our industry partners is that because it's pretty coarse, the unit of reasoning for developers who get feedback from this tool is the method. So it's quite easy to reason about a method that is not detected. By the way, we generate mutants only for methods that are reached by the test suite. So we know that a test case is passing there, but if we remove it, sometimes none of these mutants are detected. And so for developers, reasoning at the level of method is quite natural. They understand what it means to remove the body, and they also understand what it means that the test case doesn't find this. So that's the first thing we do. We have a new tool for mutation testing, mutation analysis. It's good per se because it gives feedback to the developers, and now we have it in the CI. And it's also good because we need it later to assess the quality of the tests. So the second thing we do with unit tests is that we amplify them. So amplification for unit tests is really, we start from something like this. So that's a unit test. It's written in JUnit. And so what is a unit test in JUnit? It's a bunch of object creation, method calls, and assertions, right? And so what we do is that we start from there, and then we have a machinery that analyzes this piece of code, runs it, so it's a combination of static and dynamic analysis. And it's also, so we analyze the code statically, dynamically, and we transform it in order to generate something like this. So this is an amplified version of the test up there. It's actually another test, so we generate another one. And so why is it amplified? It's because it's similar to the first one, but it will test the program with slightly different inputs, and it also increases the number of assertions. And just to be clear, the assertions that we have here are of a completely different nature than the ones we have up there, because the one that is up there is written by a developer, and the developer has a good idea of what is the method supposed to return. The developer knows the expected return value. So the assertion is about comparing the actual result to the expected one. The assertions we generate cannot be like this because our tool doesn't know the expected value. So the assertions that we generate are of a slightly different nature. We assert that the value returned by this method call is equal to the value we observed once. So here we run the program, we get the result from these values, and this is the expected value. So basically you can think about these assertions more as regression type of assertions. So later on, if the behavior of these methods changes, we will be able to capture it with this kind of assertions. So that's what we do in terms of unit test amplification. And this test case, so we generate many, as you can guess, and we keep only the ones that increase the mutation score. So that's the relation between mutation score and unit test amplification. The second level at which we work is configuration testing. So here the idea is that many programs operate under multiple configurations. So configuration, you can think about it in different terms. Either you can think about the config file for your web server, you can think about the config file for your radio base unit, or you can also think about configuration as the environment in which your system is supposed to run. So we work with a CMS, with a company that builds a CMS, for example, and for them, their CMS is supposed to work correctly with several database management systems, several versions of the browser, several operating systems, and so for them, a configuration is a configuration of the environment inside which they want to test their program. And so typically, what they do today is that they test with one default configuration, maybe two. And so the idea is to take a model of this configuration, generate more. So take a model of the existing thing. So here the existing test asset is a config file. Amplify it, so generate multiple configuration, and then have a mechanism to automatically deploy this configuration and run the test suite. So a config file, nothing really fancy here. You can recognize these things. So this is a config file for a web server. And so this is the default configuration in which the system is tested. And so amplifying configuration, what it means is that we automatically analyze these things, and we will generate another version of it. And so here the challenge is that typically these values here, they have some bounds. So we take this is done by developers currently, and the thing we ask them is to add some bounds on the values and maybe some constraints between the different values. And so this gives us a search space of possible configurations. We generate them, and so now we have another file, so we are still pretty far away from automatic testing. So the other thing that we do is that we take this file and then we automatically instantiate the environment. So today we use Docker to build some testing environments, and then we have a machine that will automatically launch the existing test cases, so typically integration tests or performance tests, and we launch them on those multiple environments that we build with Docker containers. So here the technology is very much JMeter, for example, as a performance test framework, and a Docker for running, and test containers. So I don't know if you know, there are this new technology which is called test containers, which is meant to do this. And so the third aspect on which we work on amplification is related to this idea that we have feedback from production, and we have lots of feedback. Ericsson has zillions of lines of logs, and many companies have. And among these logs, we sometimes have stack traces of crashes. So in STAMP, this is what we work with. So we typically work with this kind of thing. So again, not very interesting to look at, but the interesting thing for us is that these things exist. We can assume that they exist, and we actually know that they exist, and we can find them. Typically, you find them in your Jira, you find them in your issue tracker on GitHub or on GitLab. So you have this. So you put your system in production, sometimes it crashes, and people will raise an issue, and they will copy-paste the stack trace there. And hopefully they will also tell you which version of your system they have used. And so based on this, amplifying this, what does it mean? It means that we extract information from there, and what do we want to do? We want to generate a test like this. And what is this test? So typically when you have this kind of stack trace, you want to know where the error is coming from. And so one thing that would be nice to have is a test case that is able to reproduce the crash, which would at least tell you, okay, this is the area in which I need to find the bug, and this is the area I need to fix. And if you have this test case that can reproduce the crash, then once you fix the bug, you can also rerun the test to see if it still crashes or not. So that's what we want to generate. And so here, the technology that is behind here is also some search-based algorithm that will combine the analysis of the trace, the analysis of the source code, static and dynamic, and that will generate this kind of thing. So STAMP is about software testing amplification. We take existing things that humans produce, so either they write them like test cases, configurations, or they provide them as feedback from the production, like stack traces. And we want to take this, and through some form of automatic analysis, we want to produce more information for testing. So more information about the quality of the test, more unit tests, more configuration tests, and more crash reproduction tests. We have a strong focus on technology because we work with companies who want to try this, so they need tools, so we build those 4 tools. We also build a lot of wrapping and integration technology, so we integrate with typical build systems, so Maven and Gradle running in Jenkins. The CI is mostly Jenkins, and we also use Docker for configuration testing. And we have multiple use cases to run this, typically in the area of backend server applications. And all of this is open source, so STAMP is building those tools. STAMP is experimenting these tools with the companies. We also have research papers on this. But one of the major results is that we have the tools, we improve them through continuous feedback through the issue trackers and all sorts of DevOps technology. And we have them open source, everything is available, and you're very welcome to try it if you want. Thank you.
Thank you very much. Super.